Right, guys. So now we're going to cover piecewise defined functions. Right, and I'm sure you've probably seen piecewise defined functions. So this should be a quick overview, and hopefully this makes sense to you. So, what a piecewise defined function is a function that's made of different pieces, if you will, and they're normally those different pieces are defined by the interval. What do I mean by that? Well, for example, this graph right there, the one that we're talking about right now, is actually composed of two different functions. One that's y is equal to 30, which is a horizontal line, and another one that's 30 plus 8x minus 3. Well, as complicated as this one may look, this is just a function with a slope of 8, all right, and a y-intercept of around 6. So this way this would work is that you would only graph the top part in this domain. What do they mean by that domain? Well, that's just a little vertical sliver that's between x is equal to 0 and x is equal to 3. So you would only draw the horizontal line at 30 between those two x values. And then you would draw this linear function only in this interval, which is x is greater than or equal to 3. So basically, where you see x is equal to 3, you would draw everything to the right of that. And don't worry, I'm going to do some actual examples here where you can actually see me draw some of these functions, right? So, now this is not to be confused. This example right below here, this is not what the previous piecewise defined function is. This is just an example of an actual graph that's a piecewise defined or a piecewise function. All right. So, for example, if if I were to if I were to actually come up with an equation for this one, I mean, you have to kind of use some previous knowledge. For example, I know that this part right here that looks like the letter V, right? I know that's the absolute value. So this would be the absolute value of x. Now, how do I know exactly the absolute value of x? Well, it has the slope of 1 on both sides, and the vertex is right on the origin, all right? So now the domain that I would have to write, I would actually have to write the domain. I have to figure out, okay, how far does it go to the right? Well, it only goes up to x is equal to 2, as you can see, all right? And on the left side, it actually never stops. That arrow right there means that it keeps going left forever, right? So the way that we would write this, that you're going to graph the absolute value of x if x is less than or equal to 2. Now, why is it less than or equal to? Well, it's actually equal to because you have a what we call a filled in point right there, right? That tells you that it's equal, right? Now, on the other side, let me just switch color. This part right here, that's just a horizontal flat line. And in this case, as you can see, if I were to continue this, I would actually cross right through the y is equal to the y-intercept of 3. So I can actually say that this is f of x is equal to 3 if x is greater than 2. Now, why is it greater than not equal to? Well, because I have an open dot. That open dot tells me that it's greater than and not equal to, right? So I'm not gonna do every example on here, but you do need, I would say you need a little bit of graph paper, at least for this or your homework. I think the homework may have enough space, but we're gonna go ahead and graph a few. Okay, so I'm actually gonna go to my notes here, and we're gonna graph this one. Now, this one's actually particularly a little difficult to graph only because they chose, for whatever reason, the y would be 40, which means that I have a horizontal line at y is equal to 40, which is pretty high up there, and it's kind of difficult to draw. So what I had to do here, and of course I did have to think about this for a minute, is I made every little tick mark here 5 on the y-axis, and on the x-axis I made every little tick mark 2. All right, so this is 2, 4, 6, 8, blah blah blah, 10. All right, so I'm going to graph the function 3x if x is between 0 and 10. So this is what I call between 0 and 10. When you see something like that, it's usually between the two numbers, right? So I'm only going to graph this between 0 and 10. Now, 3x has no, or excuse me, has a y-intercept of 0, right? And since it's not equal to 0, I'm going to draw an open dot. And then, yes, I would go up 3 over 1, up 3, rise over run, correct? Well, up 3 over 1, up 3 over 1. Now, this would be a lot easier if I only had exact tick marks here, which I don't. So also what I can do just to figure out where I'm going to stop here on this side is that I can plug in 10, which is right here. It's my domain, right? I can plug that in for x, and that would give me 30. So I know that at x is equal to 10, y is equal to 30, which for me would be about right there. Now, what I do know about a linear function is that if I can figure out where 2 points are, then I can just draw a line in between it, and that would be that exact line, all right? So again, notice that I'm only going to draw the graph 3x between 0 and 10, all right? And when I say between 0 and 10, I'm talking about the x coordinates 0 and 10, okay? Now, if you look on the other side, on the bottom equation, it says y is equal to 40 if x is greater than or equal to 10, all right? So again, notice the 10 is down here. Right, so that's where I'm going to begin, and then 40 would be right here. Now it's equal to, so I'm gonna put a solid dot, and I'm going to draw everything to the right, because if it's greater than 10, it has to go to the right. So that's what that would look like. Okay, now let's go to the next example. Excuse me. Now this seems to be easier, and for quite honestly, for some of you, this is just going to be a review slash practice for how to draw certain graphs by hand without having to use a calculator. All right, so for example, the x squared function, remember what you could do with the x squared function is draw the parent function, which is y is equal to x squared, and come up with x values that give me y values that are easy to graph, like -2, -1, 0, 1, 4. Now, how do I figure out the y values? Plug in the x values, right? So -2 squared, for example, is +4, and so on. All right, so the way that I like to do this sometimes to these domains, especially when I have I actually have three functions. I'm going to take pieces from the three functions, right? So the first one's only going to be graph if x is less than 1. Now 1 would be right here for me. I'm going to draw a little dotted line. You don't have to do this. I kind of like to do it just so I can figure out exactly how far to go. And then I have, let's see, between 1 and 2, which is not very much at all. This is 2 right there. I'm going to draw another dotted line. And then finally, if x is greater than 2, okay, then y is equal to x, right? So the first part, y is equal to x squared. Remember, I started at the origin. And then I want to follow these points right there. Oh, by the way, and I have a point that's wrong. 0 squared would be 0. My bad. So the first one would be -1, 1. That's the one that I just drew there. I'm going to go to this one next, -2, 4. So from the origin, 2 to the left, up 4. 1, 2, 3, 4. That's pretty good. And on the other side, I'm actually going to do this one also. Now, I could try to do this one, remember, but this graph only goes if x is less than 1. So I'm only going to draw this part of the parabola. Not everything, just that part. Now remember, this filled in dot that I'm sort of exaggerating how big it is filled in because that's equal to 1. All right, now for y is equal to 3, don't forget, y is equal to 3 is just a horizontal line across 3, which for me, 3 would be about right there. Now, you can do it many different ways, okay? But you're only going to draw, technically, just this little part with an open dot here and a filled in dot there. Now, how do I know it's open and filled in? Well, just look at the signs. This is not equal to, that one's equal to. So therefore, at 1 is open dot and at 2 is a filled in dot. Okay, that's that. So now finally, and this is I think the part that most people have trouble with, believe it or not, is if y is equal to x, all right, when x is greater than 2. So, uh, hmm, at the peril of you not being, well, let me just keep the white color because it's difficult, right? So y is equal to x means you would start on the origin and you would go up 1 over 1, 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 up 1 over 1. Now, the danger for a lot of kids here is that they try to draw the whole thing like I'm just doing here, or they actually try to start from this little dotted line that I made, But remember, because x is only greater than 2, I do not need this side right here. All right, I only need that right side because the domain is constricting me to that area, or to the, yeah, to that area. So hopefully that makes sense to you now. For questions, I'm not going to do every single one of these questions for the sake of time. Now let's go look at 5 and 6 on your notes, because this is, I think it's easier just to do in your notes. So on 5 and 6, you're supposed to come up with the equation, all right? The piecewise define, or the piecewise function for both of these, all right? So here's how you would do it. Well, first of all, I'm going to put f of x. Let me switch to blue here. So I have f of x. And it looks like I have 3 lines, which means I'm going to have 3 different functions with 3 different domains. Apologies. So now, notice that this top line right here, it looks like is y is equal to 2. And that only happens if, now look at how far on the x values you are. -6 to -1. So we're right, -6 is less than x, or equal to, which is less than -1. So that's how you write that. You always write from the least to the greatest. Now the second part looks like this is going across y is equal to -2. So we write a -2 here, and the domain again, you can do it by just looking at the x values here. It looks like it goes between -1 and +2. All right, so next up. Now finally, in this next part, let's see, y is equal to 4 if, and sorry that I'm writing all over the place, look at the x values as between 2 and, let's see, 2 is an open dot, and I have a closed dot on 4. All right, so my apologies on this one. This needs to be equal to, and this one does not need to be equal to. All right, so that's that for that one. Sorry for the mess. I just ran out of room. Now, number 6, I'm going to zoom in so I don't run out of room. You have 2 functions. Now, you got to be able to recognize those functions. If you can't recognize them, well, you honestly truly have no chance, but hopefully these 2 are easy enough you can recognize. All right, so the first part, notice that it's just a flat horizontal line, which means you have just a y is equal to 3 function. Notice that the arrow goes to the left. Okay, so this would be if x is less than 0, right? Why is it 0? Because this value right here would be 0. Remember, you're looking at the x values, right? So if x is less than or equal to 0, that would be it. Now for the other part, it looks like a parabola, and I know this parabola is not being stretched because of this first point right here. Because if you remember, on any quadratic function, if the first point you have, one of the first points you have, could be -1, 1, 0, 0, 1, 1. If this y value is exactly where it's supposed to be, which it is, then it's not being stretched. So for this one, this is just y is equal to x squared if x is greater than, 0. Now, how do I know it's greater than 0? Because you have an open dot right here. All right. So I think that's pretty much it. Let's see if there's anything particularly difficult in your homework. Your homework's not very long. I don't want to do your homework because there's so little of it. You do have the answer to the odds down here if you want to go on ramps and look at them. And if you don't know how to graph this, yes, you can plug it on your calculator, but remember, you can just come up with the parent function to y is equal to the square root of x. The -4 means you move to the right 4, so 1, 2, 3, 4, and you're going up 1. So right here, this is literally where you're starting. And if you can come up with the x and y values for that, just come up with some x values that would be easy to take the square root of, and you should be on your way. Anyways, I hope that helped. If you have any questions,